Hello everyone, welcome to Dima Tutorials Online School. My name is Victor Onimisi. Today we are going to be looking at JAMB 2018 past questions. Before we start, if you haven't registered for our WhatsApp class yet, it is important to join others who are preparing for the same exam as you and learn with us. The fee is just 1,000 naira for each subject and 2,000 naira for use of English. Like I said earlier, we'll be looking at JAMB 2018 chemistry past question. Now let's dive in. 4. A correct electrochemical series can be obtained from K, Na - potassium, sodium, calcium, aluminium, magnesium, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold by interchanging A, aluminium and magnesium, B, zinc and iron, C, zinc and lead, D, lead and hydrogen. Now to look at this, to solve this question now, I need to understand that the above mentioned elements is what we refer to as the electrochemical series, and here now we're looking at the metals, the electrochemical series for the metal. The electrochemical series, also known as the activity series, is an arrangement of the elements in order of their reactivity, right? How strong they are. So here now we'll have the elements arranged in order of decreasing reactivity. So it therefore means now that from this arrangement, potassium is the highest, is the most reactive element from this arrangement now, okay? Then followed by sodium, down like that. Now, but something is wrong with this electrochemical series that's written here. Now, there is something that's wrong. This is not the correct order, right? So now, if you are conversant with the electrochemical series, you will know that the only problem we are having here now is the position of the aluminium and magnesium. All right, position of the aluminium and magnesium, because in the correct electrochemical series, magnesium comes first before aluminium. Why? Because magnesium is more reactive than aluminium. Now this is it. When we have our periodic table, all right, we say that the strongest metals are oriented to the left of the periodic table, most especially the group 1 and the group 2. All right, most especially the group 1 and the group 2. And then in our periodic table, we will always say that metallic property decreases across the period. Metallic property decreases across the period. Why? Because in every period of the periodic table, we are always with the metal, and as we proceed to the right, from left to the right, we keep on leaving metals and hitting on non-metals, and the non-metals continue like that. So moving from each successful period, you are going to be leaving the class of metals to the class of non-metals. So metallic property or electropositivity decreases across the period. So if you look at magnesium and aluminium, magnesium occurs first before aluminium, because magnesium belongs to the group 2 of the periodic table, while aluminium belongs to the group 3 of the periodic table. So now, moving on from each successful period, from each period, you discover that electropositivity is decreasing. So magnesium is more electropositive than aluminium. So magnesium should have occurred first before aluminium in this electrochemical series. That's how the correct electrochemical series is. So the only problem we're having with this arrangement is magnesium, the position of magnesium and aluminium. So we can obtain a correct electrochemical series by interchanging the position of magnesium and aluminium. So let's look at the options again. A will have aluminium and magnesium, B will have zinc and iron, C will have zinc and lead, D will have lead and hydrogen. All right, so now that we have that, I will leave you to choose the option. Now let's move on to question number 5. Moving on, we'll have question number 5. A basic postulate of the kinetic theory of gases is that the molecules in a gas move in straight lines between collisions. This implies that A, collisions are perfectly elastic, B, forces of repulsion exist, C, forces of repulsion and attractions are in equilibrium, D, collisions are inelastic. Now, looking at this postulate is one of the most important postulates of the kinetic theory of gases. Now, when you hear the kinetic theory of gases, it's talking about the nature of gases, and from the word kinetic, we have two types of energy. We have the potential energy and the kinetic energy, and we know that potential energy is energy at rest, while kinetic energy is energy in motion. So we are looking at the motion of gases. So first thing first, I need you to understand that gases are always in constant rapid motion. Alright, they are always moving about. Why is this? Because the molecules that is holding the particles of gaseous substances together are highly negligible. What do I mean here? Now, let's quickly explain the states of matter. Now, when you have a solid material, for example, now the solid material is compacted, right? If I have a stone, it's compacted. The molecules are compacted together. You cannot easily take, like the stones cannot just divide into separate stuffs and keep moving about. Why? Because there is a force of attraction, right, holding the particles of the stone together. I hope you know that every matter that is existing is made up of particles, which we call atoms. So there is a force of attraction holding the particles in a solid together, and that force of attraction is very, very high. Now, when it comes to liquid, the force of attraction is there, but not as high as that of a solid material. That is why you can pour liquid substances now, and they will still be together because there is that force of attraction. But when it comes to gaseous materials, that force of attraction is there, is in existence, but it is highly negligible. And it is too insignificant, it is too minute to take note of. Right? So now, that is why the molecules of gases are not usually held together, because that force of attraction is very, very small to hold them together. So they are always in rapid motion. They are separated far away from themselves. That is why we will tell you that a gaseous material does not have a definite shape. It doesn't have a definite volume, because it fills up the volume of whichever container it is in, because they are always particles. Alright, particles. Alright. And now, one thing with gaseous material is that they are always in constant rapid motion. That is, they are always hitting themselves and hitting the walls of the container. Now, this is what the kinetic theory of matter postulates as the molecules of gaseous material moving in straight lines between each collision. And this simply implies that the collision, when they hit themselves, they return back. Alright, when they hit the walls of the container, they return back. And so this whole statement is talking about the elastic nature of the collision of gases. Simplify that word, that the collisions of gaseous materials are perfectly elastic. Alright, we all know what elasticity means. Elasticity is the phenomenon whereby a substance returns to its original shape when it is being deformed or stretched. So in this case, they are able to return back to their when they hit themselves and the walls of the container, they return back in straight lines, right? So we call it the elastic nature of the collision of gases. Alright, so which simply means that option A is the correct answer. Collisions are perfectly elastic, right? It is not because the forces of repulsion exist. Of course, the forces of repulsion exist, but that is not what the statement is talking about, right? We have other options like the forces of repulsion and attractions are in equilibrium. This is even wrong in the first place. If the forces of repulsion and attraction is in equilibrium, then there will be minimal repulsion. Alright, there will be minimal repulsion. So there will be no the gases hitting themselves and returning back will be very, very minimal. Okay, and the collisions are inelastic. This is really wrong. Collisions are elastic. If the collisions are inelastic, then we would have had a compacted gaseous substance. The molecules would have been held together. Alright, but the collisions are elastic, meaning even though they are hitting themselves, they are returning back. So that is why we don't have a definite volume or a definite shape. Right? I hope you get that.